And welcome back to the channel, everyone. Today's lesson, we're going to work on more complex absolute value equations. This time we have variables on both sides, and we're going to rehash what we already know about absolute value equations. So a couple things to remember here. When we get to an absolute value equation, remember that when we have the absolute value of a number, let's say the absolute value of the number is 3, there are two possible values. You have the positive and negative version of it. So both are solutions here, which is why we will be setting up again our positive and negative equations. Okay? So that's the first thing to remember here. The second piece to remember is our job is to isolate. We always want to isolate the absolute value. Okay? Now, in this case, in this example, it's not going to be prevalent. We're not going to need to isolate it because it already is isolated. It's on its own side. But in the second example, you're going to see that we are going to have to isolate from there. Okay? So the only change here, so now we have our positive equation. And remember, a positive equation, we want this inside our absolute value to equal the positive version of x plus 9, which therefore stays the same. 3x minus 4 just equals x plus 9. The negative side of the equation means that everything about this piece over here becomes negative. So the 3x minus 4 doesn't change, but the positive x becomes negative x, and the positive 9 becomes negative 9. So that's the only change that happens here. You make the entire thing negative. Essentially what you're doing is you're multiplying this side by negative 1. That's how we get the negative equation over here. Okay? And now we just solve as we have solved with variables on both sides. Move the smaller variable. Here I'm going to subtract x from both sides. 2x minus 4 equals 9. Add 4 to both sides. 2x equals 13. Divide both sides by 2. Therefore, x could be either 13 over 2, or if you had it as 6.5, that would be acceptable. Okay? Now here, as we did in past examples, a lot of times the steps were the same. Here it's a little bit different because you have the variable on both sides. So I'm still going to move this negative x because it's smaller, but in this case, I'm actually going to add x to both sides in order to eliminate it. I get 4x minus 4 equals negative 9. Add 4 to both sides. 4x is equal to negative 5. And then divide both sides by 4. So x is equal to negative 5/4 or negative 1.25. So if I'm writing that in my set for my final solution, x would be negative 5/4 and 13/2. There's my final solution. I go to my second example. Now I have this absolute value, and that's what I want to isolate. So I have a couple of pieces where I want to use that reverse order of operations in order to solve this. So the first piece that I want to move is I want to move this positive 7. I'm actually going to add 7 to both sides to start there. And now I have 2 times the absolute value of x minus 4 equals 4x plus 16. Now I still want to isolate this absolute value of x minus 4. So that means this is 2 times all of that value, meaning I have to divide both sides by 2. And remember, you're dividing both terms by 2 over here. Okay, so now you're left with the absolute value of x minus 4 is equal to 2x plus 8. Okay? So from there, now I can set up my positive and negative equations. The positive side would become just x minus 4 equals 2x plus 8. The negative side would become x minus 4. And remember, you're essentially multiplying this whole thing by negative 1 is equal to negative 2x minus 8. Okay? And then we solve from there. Here I'm going to subtract x from both sides. Negative 4 equals x plus 8. Subtract 8 from both sides. So negative 12 is equal to x. That's one value. Over here, I'm going to add 2x to both sides. That's my smaller variable. 3x minus 4 equals negative 8. Add 4 to both sides. 3x equals negative 4. Divide both sides by 3. So x in this case is also negative 4/3. So if I'm writing them as a final solution, as my set, x would be negative 12 and negative 4/3.